Okay, here we are with January 2007, call to question 6. And we've got the equation of a graph and a lovely picture. And we are given the equation of the graph again, and we've got to differentiate it. So x plus 1 shouldn't be hard, that's call 1 differentiation. This term here we have to differentiate. So 4 over x squared, you write that as a fraction with the numbers in it, times a fraction with the x's in it, which will be 1 over x squared. So it will be a number times x to a power. Now to cause this 1 overness, what sort of power do you need? And once you've got that as x plus 1 plus something, it'll be a 4 times x to some power. Then you use your normal rule for differentiating to get dy by dx. Okay, then in part 2 you've got a minimum point at M and to find the coordinates of M. So a minimum point, which is that sort of point, is a stationary point, so that's got to ring the bell. Stationary point. The gradient dy by dx at a stationary point from core 1 you know equals 0. So you have to take your answer to part A, your dy by dx, and put that equal to 0. Now your answer to A1 should look like 1 plus some number times x to a negative power, and that's got to equal 0. And you can rearrange that until you get what x to the negative power is. You may want to multiply through by x to the corresponding positive power, but you're going to get x to some power equals some number. And then, if this is a negative power, it means 1 over, doesn't it? Not strictly necessary, you just need to take a corresponding root and you'll get what x is. Once you know what x is, you want the coordinates of M. So you're going to need to find out what y is, and you've got here your recipe for y in terms of x. Hope that helps. And then finally, find an equation of the normal to the curve C at the point 1, 6. The normal, and we want the equation of it, which is the equation of a straight line. So you need a point, that's not hard, and you need a gradient of the normal. Well, we know what dy by dx is, so you can say dy by dx when x is 1 is a particular number. But is dy by dx the gradient of the normal? No, it's the gradient of the curve, or the gradient of the tangent. So once you've got dy by dx when x is 1, you then need to say the perpendicular gradient equals, and you know how to get perpendicular gradients, and then you're ready to do your recipe y minus y1 equals m x minus x1. Don't need to simplify that, that is the gradient of the normal, so only simplify it and multiply it out if you're bored at the end of the exam. Right, on to part B. In part B we've got to integrate this, so you go back to the form up here that you integrated, so that you differentiated. So now we've got to integrate x and 1 and 4x to some power, and use your normal rules for integration, and that should give you 3 marks. And then finally, for B part 2, you've got to find the area of the region between the curve and the x-axis. And so instead of doing this, which will be an indefinite integral with our plus c on the end, I hope, in part B you take that answer and you put it between square brackets, and it's between x equals 1 and x equals 4, so we've got limits of 1 and 4. You put 4 in, you put 1 in, and you simplify and you see what you get. Okay, my time's nearly up on this, but these videos have been overrunning, so I normally, well, I'm going to talk rubbish for a, well, I'm not.